Hello, Internet. Today my name is Jeremiah. I'm Kilo November 4, Hotel Juliet, India, and today I'm going to be showing you guys how to take and use a QYT and a Baofeng together as a ham radio repeater system. To do this, we do need to make a custom board. So the traditional connection obviously will not work. Since you're going to need RJ45 on the Baofeng. However, the Baofeng has this weirdo interface to it. So what I've done is I've created a adapter board. The adapter board is fairly straightforward. One issue is the push to talk on the microphone is a little bit wonky, and there's a repeater control line. So we're going to be utilizing that and the repeater control on this guy. So that's convenient. This guy feeds into here, and inside of here we're going to have a little array just to negate. So I have a NOT gate here, and then I have a little driver transistor, and this grounds the push to talk down the ground. This causes that when this line becomes high, this guy transmits, which is what we want. Sorry, when this line becomes low, this guy transmits. That's the go. Anyways, we got 3.3 volts. That's coming into here, and the reason we have that is just to keep that transistor right there biased at all times. Because if this isn't necessarily important, but the problem is if this radio isn't on, repeater control will be floating, and that causes this network to become active, which causes this to transmit. So we need to make it high, which is a go in that case. The microphone, thankfully, just hooks up to the AF out, which you guys can find this image on the interweb. It's very convenient. Same goes for this. A little bit of Googling will get you a pinout for all that. I'm sure those are copyrighted, but yeah. Creative Commons. Anyways, our speaker minus, that just, all the grounds we pretty much just hook them together. No biggie. Speaker plus, however, we need to do some complicated circuitry because we have a push to talk, and we need to determine when that push to talk should be pressed. So whenever we get audio from this guy, we need to press the push to talk on here. Well, luckily that's fairly straightforward. We can do that with the transistor. They're great electronic switches. So what we do is we have the speaker output of the Baofeng going into a little crystal detector circuit. This crystal detector circuit, whenever it detects a fairly loud audio signal, biases that transistor, which shorts that to ground. One important note is a 10-to-1 voltage divider has been added onto the microphone plus. That's because this guy outputs a fairly high impedance, high voltage output, and this guy doesn't really like that high voltage output. This guy outputs a fairly high voltage output, which it saturates this guy, so you have to turn the volume all the way down. Doing this gives you more range with the volume. It's not strictly necessary, but I would highly recommend you use this circuit, that voltage divider. It's important. Okay, theory aside, I'm going to let you guys get a real nice view of that. Anyways, here's my cable, here's my setup. I've got this guy running through an RJ45 Ethernet cable. And going right into this little board where I threw everything together. You can see a little crystal detector, 2 transistors, little Teflon tape there, and we got it going straight into the Baofeng. For reasons, I like to test everything, doing these test systems in very low power environments. I don't like to transmit over a milliwatt. That's a good rule of thumb. I'm not going to hit any local repeaters with this, A, because I'm on simplex, and B, because I'm transmitting at a milliwatt. It's probably not even going to leave the building. Somebody would really have to be looking for it in order for this to interfere with any electronics. When testing stuff like this, you don't want to cause harmful interference to other hams. It's a bad thing to do. Nobody likes that. And people like me might hunt you down and tell you to stop. Anyways, here I have a coupler. This dumps all that power into a dummy load and transmits a little tiny bit of it. Here we got some attenuators. Again, all this is to make sure that in our testing environment we're not transmitting any harmful or interfering signals. Here we have a RTL SDR, just receiving our signal that we're going to be transmitting. This is to prove that we have a signal. So, here I have my handheld carry Baofeng. This is a UV5R. Down here I have a BF53, which I'm sorry about the lighting, but you'll have to believe me in that. This guy's a tri-bander. It's very nice radio. I got it today actually. Simplex 2. This is 446.000. 446.000. Sorry, my RTL SDR is causing some interference. This is 446.000. We're in a fairly radio quiet environment right now. So what I'm going to do is I've got my repeater configured. What will happen is when I transmit on here, we will see a signal, obviously on 446. Now we're going to hit up the repeater. One note is, before I forget, I must show you. In order to activate this repeater, you must activate the repeater feature on the QYT 8900. This is menu 43, so you can access this. They have multiple different modes. Each of these modes basically determines how the repeater is triggered. For now, we're just going to use carry, but you can experiment with CTS, S, and D, all that crap on your own time. Now, using a little bit of black magic, we just magically plugged our cable right back in. We've got our radio set up, ready to go. We're going to turn the volume down on here because where we have all these radios in close proximity, we'll get feedback. And a side note on this is different for the Baofeng. However, the volume on here does not in any way affect the volume your repeater is using. So you can set the volume to this to whisper quiet. It does not care. However, that's not true on the Baofeng, because on the Baofeng we're using the speaker pins. On the QYT 8900 we're using this AF out, which is just a raw audio signal, and the potentiometer comes after the AF out. So we're working with the raw signal here, which means the volume knob will do nothing to that signal. Either way, let's get to work and go live. This is Kilo November 4, Hotel Juliet India on frequency, doing a test transmission. Kilo November 4, Hotel Juliet India. As you can see, we have a very clear signal there, right way above the noise floor. Out of this building, nobody's going to see it because, again, I'm using coupler, dummy load, all this stuff. In the real environment, this is going to be in my car. I'm going to have this right beside of it, and, you know, if I get stuck in a cave somewhere, I can call up my radio, which is going to call up the local repeater, and I can get help or whatever. Talk to my hams. This is a cool thing to have. I think that will be it. Some notes on building this circuit. First off, I haven't had much time to experiment with these values. It's actually kind of getting rather late where I'm working. And I haven't had much time to work with these values, so, you know, you probably could improve this circuit a lot by using different parts. You might be able to add in a capacitor on the diode detector, which might cause audio quality to improve a little bit. This is one theory I have. Is this circuit is only triggering on the positive half of the audio signal, and if that's the case, well, that's no good. What that's going to do is that's going to cause your audio signal to be going through a diode, which is crappy. I don't know how this is handled, you know. You could optimize this value to more adjust the slider, because remember, this volume slider here has an effect. If you start out with it all the way turned up, it's going to oversaturate the hell out of the microphone on here. So you need to turn that way down. I normally like keep it at like 10%. So, you know, you want to be careful not to oversaturate things. Another very, very important note is crosstalk. Every RF amplifier on the planet, I don't care how good you got, you might have the best microwave amplifier on the planet, it's going to have harmonics. Like everything is going to have harmonics. So you got to think, okay, what's going to happen if this thing has some harmonics? Well, that's going to be a problem, because what that's going to do is this radio, when it transmits, this radio is going to receive it, and it's going to retransmit, and then it's going to oscillate all around, and that's no good. So the thing we can do to fix that is get really far apart. In my case, here I'm on VHF and here I'm on UHF. I'm on completely different bands, so there ain't no chance of any crosstalk occurring. It's not going to happen. If we were using the same band here, we might consider adding filters to these inputs. Maybe let's see here, a little VHF bandpass. That might be something we want to add. Now, obviously, this is not going to handle the power. It might from Baofeng, but it's not going to handle this kind of power. I mean, we got 3 dB of loss, that's going to be 50%. This thing's going to have to dissipate half a watt of heat, and it's not going to do that. That's going to melt. It's going to burn up. It's going to blow up. So, you want to think about crosstalk in between these systems. You want to make sure when you build this, I recommend using nice, well-made, shielded Ethernet cable. Put a good LC filter on your doohickey. You don't want to, I mean, you could add an LC filter to this thing, but it's got a battery. Batteries are basically infinite capacitors. You're not going to have noise on that. But assuming everything's powered from battery, you know, optimally, you probably want just to use a battery on this. You don't want to use a car power supply, because cars, they're noisier than hell. And, yeah. This, where it was mounted in the car, a big chunkin' LC filter was actually really good. It improved the performance of this greatly, because the environment inside of most automobiles is noisier than hell, mainly since you have so much connected to the same exact 12-volt bus. Other than that, I think that's pretty much it. Like, comment, and subscribe. If anyone has any suggestions for how I could improve this circuit, please post them, because I'd be happy to improve mine. I hope this comes in handy, and to my knowledge, this is the first time this has been done on the internet.